Hey, good afternoon, everyone. My name is Tom Douglas. I'm with Reiko. Thank you for joining us today on this month's webinar on using ultrasonic meters for successful energy metering. Joining us today is Dan Kilpatrick. You may recognize him. He's, I think it was the second, maybe third time that he's hosted a webinar for us. So yes, we greatly appreciate his time. For those who don't know Dan, he's been with GE for a while. He's got over 25 years experience in instrumentation and controls. So he's pretty good at this stuff. So a couple of housekeeping items. We will be recording the webinar so that if you missed it or dial in late or wish to share it with someone, we will have that available at our website at reiko.com. Also, if you have any questions during the presentation, there is a little chat box in the kind of upper right-hand corner of your screen. Please use that, or rather than chat, questions rather, use the questions tab, and we will get to those as soon as we can. Outside of that, Dan, I'm going to pass the torch over to you.
Thank you, Tom.
Thanks again.
All right, appreciate it. Thank you, everyone, for attending. So let me show you the agenda. And what we have, an hour or less than an hour? Is that what?
Yeah, trade. Okay, probably about 45 minutes.
All right. We'll go over the types of energy use, where to meter, why to meter, talk about the technology. Now, Tom said it was ultrasonic meter. I included Vortex because it is another product that can fit into this space. So we'll touch on that. But focus then on the products as they apply to liquid and steam, talk about some advantages, and then finally offer some case studies where we can show that this stuff has worked, why it's worked, and that sort of thing, and some resources for anybody who needs some extra help and maybe has not done an energy management project. I have some links to some companies that can certainly help you with that. So the types of energy use we're going to talk about here. And, today energy costs are not quite what they used to be, but I feel, as most probably do, that those costs are going to go up. So it's good to know about these things. Some things that customers typically will measure: chilled water, steam, high temperature hot water, electric, compressed air, and natural gas. Now, using ultrasonic meters, obviously, we can't do this for electric, but it's up there nonetheless. We do get a lot of questions. Hey, you're GE. You should be able to sell us electric meters. Yes, we can, but not this particular group that Reiko works with. So, where would you measure energy or use of energy? Well, looking back here at this list, you've got chilled water, steam, and natural gas, and compressed air. So you'll have all those variables tied into central utility plants. And then we have a term called campus energy. Campus energy is where you would find a not quite as big of a utility plant, but a pretty much a central plant. And it's diversified over several buildings, so it's the campus aspect of it. We see campus energy projects at universities, hospitals, industrial plants where they have multiple buildings scattered across a industrial park, pharmaceutical, the same sort of thing, and food plants. Food plants are notorious for using quite a bit of steam. So hopefully people in the audience fall into one of these categories here. There's a concept called SubMetering. And just for some clarification, I thought this would be a good graphic to put up, and it kind of tells the whole story, where you have a cogeneration or electric substation and a district chilled water plant all feeding into buildings. So you see that yellow arrow pointing up at M. M stands for meters. So within these buildings, they're looking at, again, these things we talked about: steam, high temperature hot water, chilled water, and those sorts of things. So when we talk about submetering, this is where we're at. Now, you could, of course, measure upstream these sorts of things with this technology, again, for usage purposes or just for data, or just to know if somebody at the plant wanted to know that. Now, why would you want to do this? Well, we used to always say it's, you can save money, I suppose, and that's true. But in a lot of cases, you want to even establish a baseline. You don't even know what you're doing. So, we talk about ideas like data, just for the data's sake, so you know where you're at, right? To reduce the energy, to control or optimize the plants and buildings that we talked about. Perhaps there might be an issue with billing. So you want to prove that your billing is accurate if the utilities are billing these separate buildings. Regulatory agencies, the EPA is dictated, or I shouldn't say dictate, put forth some compliance laws such as MACT, which is maximum allowable control technology, and the NSPS. These have to do more with things coming down the road or already been in place where we're measuring flare gas flow and that sort of thing. I put it in there because it is still energy related, but our focus isn't going to be so much in that particular world. And then finally, just establish existing conditions. Once again, you don't know where you're at if you don't measure it, right? Very true. All right. I will put this slide up later for reference with the resources. And let me shift gears here. Stand by. Okay. So back to our agenda. We're going to focus for the next, probably most of the presentation here, on the different technologies as in the GE portfolio of products that match up with the energy management packages. So I love this line. If you cannot measure it, you cannot improve it. And there again, Lord Kelvin knew what he was talking about, right? We don't know, I suppose, is another way of saying this. So there's a couple examples that just out of our marketing group, projects we've done over the years. And we'll probably refer to these a little bit later as we go on here in more detail. But the architect of the Capitol has put in quite a few of our meters. So I guess we can thank ourselves because we paid for that, right? We have some steam flow and some gas flow, or excuse me, chilled water flow in this example. Universities, we talked about those earlier. A couple more examples, a few more here actually, where cooling is involved, cooling water. We'll talk about the technology we use for that. Chilled water, steam as well. Another example is the pharmaceutical, pointed to that earlier. Another campus energy sort of situation where we're putting in chilled water meters. All right. So the technology we're going to talk about is twofold. We have ultrasonic and also vortex. Ultrasound, this is a quick primer on the technology if you're not familiar with it, is anything over 20,000 kilohertz. We use transducers, if you can see on this picture here. I don't know why the guy's in a canoe, that's interesting. But you have upstream and downstream transducers, okay? So you're sending and receiving, and then sending and receiving, back and forth, using ultrasound. So we're using that concept to get velocity, which is this guy here. There's some other variables here, path length and axial length in this theta. I'm not going to go into too much of that, but to tell you that we derive velocity by knowing what this time up and time down is. So if there's no flow here, if they're sitting in his canoe not doing anything, the delta T is going to be 0. As he starts moving from left to right with greater velocity, it's going to take longer to go up than it is down. So our T up is greater than our T down. So this is happening rapidly, and the delta T times are expressed in, I think, microseconds. So 1 times 10 to the negative 6. So we calculate velocity. If we know the cross-sectional area of the pipe, we can give the gallons per minute. So we offer this technology. This is shown as a wetted configuration, but also clamp-on. And this picture is kind of small down here. It shows an example of a clamp-on arrangement, and this is a wetted. So there's a few items here that are common. One is the transducers. Okay, you can see them here and over here. The cables, couplant, the electronics. We'll talk about the reasons perhaps later why one would want to choose wetted or clamp-on. I think it's fairly obvious just by looking at it. Clamp-on's a lot easier to set up. You don't have to schedule an outage or break into the pipe. And wetted, of course, it looks, when you look at this, just a flange connection. So, all right. The next technology is Vortex. Quite simply, Vortex is also using a piezoelectric type of crystal or velocity sensor, but in this case, we're generating vortices by using a bluff body. So this concept's been around for probably 100 years, I guess. This is the constant wavelength. The greater velocity you see, the more vortices you pick up or distribute, and that's proportional, of course, to the flow rate. So we have similar sort of arrangement here, inline, and we also have an insertion. So this actually goes into the pipe. Well, they both do, but this is a little more easier. I guess the insertion is a little more easier to put in service. We have retractable technology, so you can, in theory, do it during without scheduling an outage. Let me take a water break here. 1 second. Okay. So with this technology, we're going to focus on both liquid and gas. Gas primarily being steam. Technology is pretty much the same as we explained how this stuff works. But some of the capabilities and features and benefits are a little bit different. This is our flagship product called the DF868, and it offers probably the most value in terms of being able to use it for chilled water. We see where we have in this graphic here the same sort of arrangement. It is a clamp-on. Can be used with a wetted configuration as well. Where we're actually, with this package, give you the ability to calculate BTUs. So you can see here, there's the electronics. Here's our transducers and clamping arrangement, and cable connecting the two. So when you set this up, you can engage it so that it can display the BTUs, you can do tonnage, you can use it for different combinations of liquids, glycol and that sort of thing. But this one is probably, you'll see this in the previous slides, those examples of where we're doing a lot of the work for chilled water. You'll see this particular product in service. But the way we're able to do that, you can see these formulas here, the energy rate. We get velocity through our meter. We input these temperatures, and then are able to calculate the energy rate or the enthalpy through this formula. So the meter is grabbing all this information and reporting it out locally or through the building automation system, perhaps that the client has. And more detail about the DF and these are the clamp-on transducers. This is an example, I guess, or a picture of the RTDs. Don't have to go with this arrangement. These are surface mount. A lot of customers will go with a wetted configuration, a little more accurate. But this is available as an EMA 4X, PC programmable, all kinds of outputs, Modbus, TCP, BACnet, excuse me, HART, and as I said before, energy management capable. Now, one thing I didn't point out, but it should be apparent, this technology can be used in multiple pipe sizes. These same transducers, for the most part, are workable with 2 inches on up to 200 inches. We have another rig or setup that can go from 1/2 to 2, but most of the chill water systems are going to be 4, 6, 8, 10, 12-inch lines. Might be ones that I've seen anyway. Along with this is our stripped down version, the AquaTrans and the AT600. This is a newer product that's going to take the place of this guy here. But these don't have the energy capabilities. In other words, they can pretty much read velocity and volumetric and do the totalizing for you. But if you want to do energy, you'd have to take this output, the velocity or volumetric, take in those temperatures, and do the math somewhere else. We do have customers. I think one of the examples I'll show you at the end here, case study, is one of those customers that's done that. Number of points, they didn't want to figure to spend the extra money to do it, and they had a Johnson Controls, I believe, building automation package that would allow them to take this and do the math and give them their BTUs or excuse me, tonnage reporting. So it's another way to do the job. Similar transducers. This is I guess a graphic of a job that we did. It has a paddle wheel spool piece that we're comparing it to. We do see a lot of this sort of arrangement in the water and wastewater markets. It's available as a single or dual channel. By the way, the other meter is also available as a dual channel. And more of a description of the newer package, the AT868. We've streamlined the mounting arrangement. In the past, it does take a little time to set these up, but this track, in essence, makes it a lot quicker. If you've got a lot of installations, mostly beneficial for a contractor maybe starting these up. You can, really get the job done a lot quicker. Same sort of communication capabilities. It is, however, only a single channel, but I believe that the cost is such that you don't feel it if you do or had opportunities where there are multiple locations. Okay. Now, this is kind of our bread and butter here, the transport. And you'll see down here, this is a portable device. There are a lot of opportunities or perhaps a lot of customers that they just don't know yet if this is going to work for them. Well, luckily, Reiko has an organization called Reiko Rentals, and they can rent these and limit your risk if you wanted to try it. I don't know if they rent these two guys here or not, but we certainly can help out. There's other resources, as I said earlier, that I can point you to help you with this. But the nice thing is you can actually bring this meter out, and Tom and I have done this before. Go on site, verify pretty quickly if this technology is suitable, if it's going to work. And there's diagnostics built into the meter that will give us that assurance. But this guy right here has the same sort of capability in terms of energy. So you can actually run in some temperature, get your BTU or tonnage calculations on the spot. So nice tool to have, and we do see a lot of activity with it. So just to recap on advantages, this is on the liquid side again, of the ultrasonic measurement. There is no pressure drop, as you might expect, because we're not really in the pipe. And even if we are, there's nothing there to really impede it or create a drop. Bidirectional, didn't really bring that up, but it is of interest. You'll see later with steam flow, in particular condensate, where there could be bidirectional flow, and it would be of interest to the customer. We can offer that, right out of the box. No moving parts, nothing to wear out, that sort of thing. No drift, periodic calibration is required. I think there's another slide here that gets into some more detail. Same sort of thing. More advantages as you try to tie it to time and money with installations and that sort of thing. Okay, I think the next section has to do with, yes, steam flow. And a lot of this will look similar because, once again, the ultrasound is still the same. We're using different frequency transducers for gas than we are liquid. That's about one of the bigger changes. But this will look familiar too. This is our GS868, and we offer this as a wetted solution. So you'll see in this arrangement an actual flow cell. The transducers are here and here. And we will be able to compute flow and offer tonnage, or excuse me, pounds per hour mass flow if we take in pressure and temperature and compensate for it. So it can be used for saturated, superheated. The steam tables are built into this guy. And you'll see in a minute here some of our limitations on the temperature. There we go. So we offer different transducers, as I said, mostly related to temperature and also here pressure. So the T9s, we can go up to 450 max Fahrenheit and 250 pressure. And our bundle guide transducers, which the transducers are up here, and this is a kind of like a buffer, if you will, to protect it from the heat. You get up to 1,110. And that's up there. There's not a lot of technology, as far as I know, where you can provide this sort of solution with that temperature. So the GS is available as a dual channel. We have packages where there's some customers that for certain accuracy reasons and that sort would elect to go with a multiple path unit. Same sort of features as before. PC programmable, multiple outputs, inputs, excuse me, for temperature and pressure. We also have a transmitter version up here for those customers that perhaps don't want all the I/O. That all they need is just something on a wall and some angle iron, or maybe right on a standoff right on the pipe itself that will give you a display. This also is an XP. So for maybe the industrial customer that has hazardous location requirements, this might fit better, than this guy here. One of the biggest advantages that we see with the steam as it's used with the ultrasonic is, I have to say, the turndown. And you'll see some other technologies. This isn't the best picture here, but it shows pitot tube, orifice plate, turbine, vortex shedding, that sort of thing. And it shows the turndown. And pitot tube does the worst, I guess, maybe 10 or 20 to 1. And we are boasting 150 to 1. And that's huge, because in the world of campus energy, there's what's referred to as a shoulder season, and that's the time between winter and spring and summer. And your loads may vary to the point where they would just drop off and you just never were really able to measure those low loads. Well, here you have one device where you don't have to change elements or anything like that. And it offers the same benefits we talked about before: bidirectional flow, no pressure drop, no moving parts, that sort of thing. But it can give you that wide range ability.
Hey, Dan, real quick,
Yes.
regards to turndown, if we have somebody that's on that maybe is new to measuring flow, what is turndown and why is it important?
Thank you. Got to be careful here.
That's okay.
We talk about turndown in terms of rangeability. So in the case of, let's say, steam flow, and we talked about velocity, right? And we'll say that's feet per second. Most other technologies, well, these other guys here, their low ends, shall we say, is 3 or 4 feet per second. Ours, we can detect down to 1 foot per second. So, if we translate that into meaningful numbers, off the top of my head, like say a 6-inch, 150-pound steam, saturated steam line, that means you may be able to go down to, 100 pounds per hour instead of, say, 300 or 400 pounds per hour. That becomes significant for those instances, as I said earlier, where we are on that edge of the shoulder season, or where low load conditions. Again, the customer said, I can't measure it anyway, so I'm not going to. Well, here you can. And again, it's a big thing for us. We kind of beat on it all the time, because people just, they never thought of it before. And so thanks, Tom, for, hopefully, did that make more sense?
That probably helped clarify a little.
All right, let's talk a little bit about vortex. You see here is two versions, an inline version and an insertion version. And this kind of blows up, the technology and the pieces and parts. We talked about a bluff body. This is what creates the vortices. This is the sensor itself, the velocity tab. And we offer, I guess, this just shows we can calculate if we take pressure and temperature in. We can do the mass flow and the BTU calculations as well. Different capabilities, different animal. This technology has, again, been around for quite a while. I suppose you could say they're kind of all the same, but they do complement the ultrasound because there might be some cases where the velocity is so high that it's greater than 150 feet per second, right? The vortex meter is happier, low velocity stuff. So we actually have some applications, mostly in the, I want to say petrochem world, where they would elect to use both technologies. So they'd have a vortex meter, side by side with a ultrasonic. So doesn't happen that often, but so it does complement the ultrasonic. Advantages with the vortex, the fact that you have the multivariable aspect of it is nice, high reliability. Insertion, this guy right over here, this is a little bit more, this is a retractable, but it's a one-size-fits-all type of thing. So, and it's got one point of penetration for all the multivariable, which aids in the cost, I guess, of installation. You don't have to tap separate spots for the pressure and temperature. Lower pressure drop, not as low as ultrasonic. I guess that pretty much covers that. I guess one other thing, but we talk about pressure and temperature compensation. This is an interesting example of why it's important, because let's say you're doing a 4-inch line and it's normally clicking along at 350 F, 100 pounds, superheated, and all of a sudden your pressure drops 5 pounds. And we don't pressure compensate for it. What happens? Well, what happens is in this example is I've just given myself a 4.8% error. The meter's not compensating. It's still going to click along thinking it's 1,000 pounds per hour. So I guess it's kind of common sense, but we do get that question, and this gives you real world numbers as to what happens, even if I shift 5 pounds. So it is important. We do offer services. We'll talk about this, I guess, with the resource aspect of it. Reiko Rentals, will put a plug in for that right here. They have a fleet of these meters and these sorts of arrangements. They've even gone as far as providing battery packs. So when you're doing these surveys, sometimes outdoors, you can't run line power, you can't recharge these things, even though they do have battery. So they're essentially like motorcycle batteries, and so you can run these things for weeks at a time, and I think that's a nice solution that Reiko has offered. Let's see if I want to, yes, case studies. All right, take another water break. Stand by. All right, this is chilled water. This is a big one. We do these day in and day out. Be nice if we did them day in and day out, I guess. University had a large chiller plant, central chiller plant, fed multiple buildings, and damned if they didn't know why they were running out of cooling. So first step, right, you have to measure it, see what's happening, and so they could make some improvements in their system. I believe this particular university was using the AT600 package, which was tied into the building automation system, so they could get their BTU calculations. So, why'd they do it? Main reason was invasive. The cost associated to hiring a contractor to go ahead and, tie into these lines, and not only that, but the logistics of scheduling an outage, they just didn't have time for it. They wanted to get on it right away. So they, along with some of our people, put 65 of these guys. Yeah, there they are, the AT. And you know, great success story. They had them running within 3 months of the delivery of the meters. So they were quickly able to, you know, find out which buildings were the so-called energy hogs and get on it and start to fix their problems there. Now the other one has to do with steam. And again, another university or central, you know, campus energy type of arrangement where they had 2 heating plants. They've tried a lot of different technologies. We showed that slide earlier about Turndown. They tried orifice plates, they tried turbine meters, and condensate return meters, and they all, you know, they struggle with each one of these. Condensate or the turbometer is more of a mechanical issue. They run on bearings, and over time bearings wear out. You know, they moving parts and so forth. So they elected to give us a shot, and here, I'll repeat myself a little bit here, but the orifice plates failed, no turn down, and a lot of energy loss there because of pressure drop. Condensate, there were leaking traps, reverse flow was an issue, and that sort of thing. Turbine meters, they find they had to replace the rotors too frequently, and they had calibration issues on top of that. So they save money, eliminating the pressure drop. Here you can see as an example of probably before installation. Yes, where they would, you know, put in the stored arrangement. Higher turn down, better accuracy, and low maintenance. I think. Let me go back, talk about resources for a minute. Let's see, there we go. I mentioned Reiko Rents a couple times. I'll mention one more. Yeah, let me go to here. Thank you. I should have done a bigger screen on the other ones too. It's okay. Reiko Rents has a fleet of the portable meters. Now they just got a hold of a portable gas meter, so that's a whole different animal. If you do have applications, let Reiko Rents know. There's their website or their link right there. We can talk about that. We do get quite a lot of inquiries. It's like, hey, Dan, we know you can do clamp-on liquid, but can you do clamp-on gas? The answer is yes. Can you do clamp-on steam? Yes, but a lot of caveats there. So let us know what those applications are, and we'll be glad to talk to you about them. Sustainable Steam is a third party that is using our portable, and they can help you if, like, say you want to rent something and you don't have the manpower, the resources, or the technology, or the wherewithal to actually do the work. This fellow at Sustainable Steam will do that work for you, give you a nice report, and has done a lot of other energy-related projects as it relates to boilers. So another good resource right there. The third one down, Jim McCauley. I mentioned compressed air at the very beginning of our presentation, only because it is energy-related. It takes, you know, energy, electricity for the most part, to generate compressed air. So, you know, every now and then you do get requests, particularly users, big users of compressed air, to audit their systems. Well, Jim has been on the job with different food plants. I worked with him years ago, where he'll actually perform audits and help customers identify where their losses are and make recommendations to improve the efficiency, thereby saving energy with compressed air systems. And then finally, RMF engineering. If you need help across the board about a big project, say, you know, where you wanted to you know, put in these meters camp-wide, and you want to take it to the extreme of actually going online with this information, and then, you know, how do you interpret the data? What do you do with that data? That's their specialty there. So I think that was kind of it. If I'll go back to this other slide here, I guess, if you wanted me to there, Tom.
Just the ending slide, or just continue on there is fine. Yeah, there were a few questions that came through, kind of application questions. One, somebody wanted to know if the ultrasonic works well with natural gas.
Clamp-on or wetted. There are two different ways to do it. We have a specific meter called the CTF 878 that was designed for the gas industry that's clamp-on. That will work well. It's not necessarily a portable, but if that's an issue, for sure. We do have other technologies, wetted. It's called the GM 868. That will work well with the gas, but you know, if it's clamp-on, we have a portable, another looks like our PT 878. We got to be careful with pressures with this particular animal. So if we could learn more about the application, the pressures, and straight run and that sort of thing, yeah, you know, we could definitely talk about that.
Again, you have some of the pictures you were showing with the actual, you know, the meters clamped on a straight run. Are there any requirements at all for how much run that you actually need to have? Vertical, horizontal, does one work better than another?
Yep. Thanks. And you know, it's an application question, and for the purposes of this discussion, and we didn't get into all the application details, but the rule of thumb with most flow meters is, anybody who's done this for a while knows, with liquids anyway, it's 10 up and 5 down. So 15 diameters of straight run. So if you had a 12-inch pipe, you'd want 15 feet of straight run. And you want to locate that instrument 2/3 up and 1/3 down of that straight run. In other words, of any obstruction, whether it's an elbow, a T, or anything like that. So we have more straight run upstream to make it so that the profile is characterizable. In the terms of fluid flow dynamics, it's either laminar or turbulent. With gases, excuse me, it's you want 20 and 10. You know, so you've got quite a job on your hands if you're looking at bigger lines. There's some workarounds with this. There's flow straighteners and things like that, but then you introduce a pressure drop, so there's some trade-offs there. Yeah, I mean, those are, and with regard to vertical and horizontal, on liquids, if it's preferable to go with on a vertical with the flow going up, that way we're ensured a full pipe. If you can imagine, we don't have a full pipe, we're going to run into some problems. So,
good to know. Again, the ultrasonic and vortex, I guess probably the biggest advantage of using the ultrasonic is that turn-down ratio talked about. Or is there anything else that someone would look at an ultrasonic and go, that's going to be a better solution for us than a vortex? Yeah,
and it is. You know, I look at it in terms of you know, fitting the meter for the application, as you should. But you know, I want to say, you know, 1 or 2 feet per second is definitely doable with the ultrasonic all day long. The vortex, it likes to see 3 or 4 feet per second. So that, to me, is probably the biggest differentiator. Cost could be another, I suppose. You're talking an ultrasonic solution versus a vortex, particularly the insertion vortex, where it's kind of a one-size-fits-all. On a 10-inch line, you know, it's going to be probably less costly, I would think. But on the other hand, how important is it to you, you know, to get that low end of the measurement, right? So we kind of have to know the whole story there, I suppose.
Sure, makes sense. And you talk a little bit, you can use these on steam or gases. The clamp-on will work for that if the application is right.
Right. The limiting factor for clamp-on steam, well, let's just say, you know, temperature is one of them. We would elect, in most cases, to go with a wetted configuration for steam. They say it has been done. For clamp-on gas, not as much of an issue, temperature for sure. Accuracy is another issue. Wetted offers better accuracy than clamp-on. And once again, we got to find out, you know, what's most important, I guess.
Sure.
You know, for what you want to do.
Yeah, makes sense. All right. Doesn't look like we had any other questions come through. So the slide we're on right now is, go back to that 1 second.
Nope, sorry.
As we were mentioning, we will have this the webinar available on our website, reiko.com, and you can also see some of our past webinars. And there's some other ways you can follow us, either on LinkedIn, follow us on Twitter. We do have a YouTube channel as well, so if you've got some instruments out there and you're trying to remember how to use it because it's been sitting on a shelf for 6 months or a year or longer, we've got a lot of good videos there that should be able to help you out. So actually, it's coming up in a couple of weeks. We're doing another webinar on HVAC measurements, so kind of along the same line here, but we've got Bob Bowe coming in from TSI. It's going to be helping out with that. So without further ado, we appreciate Dan, again, thank you so much for joining us, leading this. If there are any further questions, yeah, please let us know. You can email me at tom@reiko.com, and I can help get you in contact with Dan, or hopefully can answer the question myself. We'll find out. So that's going to be it. So thanks everyone for joining, and we will see you next time.
Thank you.